Hi, in this video I'm gonna be showing you how I created a license plate for the use in DAZ Studio. Even though this might be a fairly simple asset, I did learn a lot creating it, and I invite you to join me on my journey. This time I built the asset from the scratch. There is no need to buy anything, nothing to import, just straight Blender. My license plate is a very flat object, but I still wanted to have some volume, so I start out with a cube. I'm in object mode, and in the viewport menu I select Add Mesh Cube. And here it is, but the cube also goes below the ground plane, and I want to correct this. In the snapping menu I activate Absolute Grid Snap. Now I change to the edit mode. I'm using pie menus because it's quicker. If you also want to use them, you can activate the add-on for 3D viewport pie menus in Blender's preferences. I make sure that I can select faces in edit mode, which you would do by clicking this little button if you don't use pie menus. Now I select the cube's bottom face by clicking on it. In order to move it, I must select the Move tool. This brings up a gizmo of which I can grab the respective arrow to move the selected face. Blender makes it clear in which direction I move the selected entities by highlighting the respective axes. Since I have Snap activated, we can see this by the lit up magnet button. The face snaps to the grid and finally to the ground plane. The little orange dot in the middle of the face marks the origin of the object which Blender created automatically on the creation of the cube. Originally it was in the center of the cube, but since I moved one of the cube's faces in edit mode, it's now on my object's bottom. If I were to move the cube in object mode, the origin point would also move, but in edit mode it stays where it is unless you command otherwise. By pressing A, I bring up the pie menu for selection, and with Select All Toggle I can select the whole cube. This way I move the whole object's geometry, and because snapping is still on, it moves in the grid's increments. The location I'm choosing here is for having a convenient pivot point at the edge of my final object. Next I want to give my license plate rounded edges, and since I'm dealing with edges I activate Edge mode. Now I can select an edge, but if I press Alt Ctrl and click on an edge, Blender will automatically select an edge ring. As so often there are multiple ways to do things in Blender, you can also use the Select menu, select loops and then edge rings. Or press Shift Ctrl Alt E like I did in this example, demonstrating what an edge ring looks like. Now I can bevel the selected edges. Let me show this from above. I press Ctrl B and I get this dotted line from my mouse pointer to the center of the selection. If I move my mouse outwards, the edges get beveled. I can set the amount of beveling by moving the mouse in and out. Let me show this to you more in detail because it's really cool. Please also note what buttons I press. So again, I select the edge ring and press Ctrl B for bevel. Now I move the mouse until I get the right size. But if I rotate the mouse wheel, I can determine the number of segments my bevel has. By moving the mouse, I still can change the bevel's size. I only have to take care that the bevels do not get too big. If they touch each other, some nasty things happen. If I don't want to set up my bevel that interactive way, Blender offers an alternative. With a simple click I let go of the interactive setup and a little menu button appears. There I can enter distinct values for the width, number of segments and many other things describing the bevel. My license plate will just be a detail on a vehicle, so I don't give it too many segments. Each segment means that there are at least 2 vertices and many more to come, as we will see, so I don't want to go overboard with the amount of geometry on that thing. Since my viewport is in box select mode, I can simply drag a box over my mesh and everything visible gets selected. Please note that in this view there are also hidden vertices on the back of the object, and the box does not select these. You can also see that each edge has little dots on its ends. These are the vertices. Blender shows them because I'm in vertex mode. My move gizmo is still there, but now it moves vertices instead of faces. Because all vertices around the top face are selected, I move the face evenly along the y-axis. And you see, also the Move tool has its special menu for manual entry. Now that my license plate has its proper thickness, I can sculpt a frame. I select the top face and press I for inset. As with the bevel before, I see the dotted line and I can adjust the amount of inset by moving the mouse in and out. Once I'm happy with how it looks, I click and get the menu again. But this time there is nothing for me to set and I can go on creating the pocket. I'm gonna use the extrude function, but let me explain this one before. Here I have a cube primitive and it's subdivided so that the top has 9 faces. I select the middle one and hit E for extrude. The blue move indicator line appears and by moving my mouse, the face will move along the indicator. With a simple left click I let go of the extrude mode, and that's it. I extruded a face and Blender took care of creating a consistent geometry. We can see that it only moved the selected face outwards, so it's hollow on the inside. And that also means I can create a pocket by moving the face downwards. But does it always move the face along one of the 3 axes? No, and I can show you. Here I created a face not being coplanar with the XY plane. And if I select and extrude the face, we observe that it moves always in a right angle to the selection. The right angle is also called normal vector and all faces have their own. Blender can show those. If I open the Mesh Edit overlays, I can select Display Normals and every face will get a small line in its center indicating the normal. The extrude function will move along this line. For now it's good, but we will come back to the normals because there is more to it. And with that knowledge, it should be clear how I create the pocket in my license plate. Now I have my frame, but the thickness of the plate itself is a bit hard to estimate. So I activate the X-ray view in the viewport. My object becomes transparent and I can see the distance between the inner plane and the back face of the license plate. The keyboard shortcut Alt-Z toggles between the X-ray and solid view. In one of my previous videos I talked about objects with beveled edges very often looking better than those without. And my license plate is not different from that. So I apply bevels around the edges. Now, to make it clear, even though I again speak of bevels, and also the Blender function is the same, this time the bevel serves a different purpose. The bevels I'm gonna apply now shall take away some sharpness from the edges, because in the real world objects almost never have razor sharp edges. A rounded edge will reflect the light into different directions and therefore even emphasize the edge. I already showed you how I bevel the traditional way, but again, in Blender there are many ways to get things done. I also can bevel with a modifier. Let me show you. In my demonstration, I'm in object mode and the object is selected. In the right panel area I can find a tab with a little wrench on it. That's the modifier tab. In the beginning there is only an Add button which I click to add a modifier. Blender offers a ton of different modifiers. In newer versions they are even organized in submenus. I go for the bevel modifier. The modifier tab now shows a panel with settings. Also, you might have noticed that the viewport immediately shows the effect of the modifier, which leads to my object to appear beveled. I can change the parameters of my bevel on the fly and observe the effect it would have on my object if it was applied. You heard it right, if it was applied. You see, the whole point of the modifier concept is that they don't alter the actual mesh, at least not until they are applied. If you want to see how the mesh would look like afterwards, I can set the viewport shading to wireframe. But now it's all transparent, and if I don't like that appearance, I can also see what's going on with the modifier by adding an extra overlay. In the viewport overlay settings, I tick the checkbox for wireframes, and now I can see the mesh while the shading is still on. Modifiers can be stacked, their positions on the stack can be reordered, they get saved in the blend file, and they are non-destructive until getting applied. So all in all, modifiers are very powerful, but they also come with downsides, one of which is that they get applied to the whole object, like you can see in my example. I don't want to bevel all my license plate's edges, especially not the inner ones, as you can see here. I only wanted to affect specific ones, like the outer edge loop I selected now. The bevel modifier can't do this out of the box, but there is a little trick. Well, it's not a trick, it's just how it works in Blender. Here I have another demonstration object and the two edge loops I want to bevel are already selected. In vertex mode you can see that there are also a whole bunch of vertices in that selection. In the properties area I have the data tab selected and I opened the vertex group subpane. There I can create a new group with this little plus button on the right. It's always a good idea to name it to something you can remember. With the Assign button I can add the currently selected vertices to the group. I can prove that they are in the group by unselecting them, just click in a free space in the viewport, and then I select all the vertices in the group with a dedicated Select button. And with this preparation I add the bevel modifier, which of course affects the whole object. But there is that limit method selection box in the modifier settings. This allows me to select vertex group as a limiter, and that again opens another selection box where I can select the group I previously created. And now we see that only my desired edges are beveled. Because it's such an ordeal going through so many steps, there are third-party add-ons simplifying this process for us. HardOps, for instance, doesn't cost you an arm or a leg, but it makes beveling and so many other operations very simple. Let me show you. I press Q to bring up the HardOps menu. Then I Ctrl-click the Mark entry for entering the bevel mode. Yes, it's Mark for bevel, don't ask why. But then it behaves pretty much like Blender's own beveling, just that in the background it automatically created the vertex group and the limited modifier. And as I mentioned before, I can still change the parameters. This way I create the bevels to my likings. Soon I'm happy with geometry and I prepare for the first export to DAZ Studio. In File, Export, I select Wavefront OBJ and an educated guess tells me I should scale the output 10 times. The rest I leave as it is and hit Export. Importing OBJ files in DAZ Studio is easy and I covered this in various previous videos. The object gets imported without any problems and seems to be looking good, but while playing around I notice some ugliness with the shading. While the back face should be one even plane, it shows that weird shading as it was wavy or like. If I ray trace this and I apply a grey plastic material, it looks odd as well. The inner part looks okay, but on the sides I again see faint artifacts. Now I wonder if something bad happened to the object's geometry, but a quick check in Blender also shows similar ugliness. In DAZ Studio I switched to wire shading mode, but nothing unusual there as well. The thin lines come from the automatic triangulations because DAZ Studio can't do n-gons, which some of the faces are. It took me a while to figure out what happens, but the outcome is quite interesting and has to do with how shaders work. Here you see me already desperately creating a cuboid from absolute scratch, so I don't even use any of Blender's built-in shapes. But with this object I had no shader problems whatsoever, not in the OpenGL preview nor in the Iray render with an applied material. So I created a simple beveled test model. The object does render well in Blender's preview, but looks problematic in DAZ Studio. For a short moment I suspected the automatic triangulation. You can see it if I switch to the wire shaded mode. Even though what DAZ imported looks reasonable, I decide to triangulate the faces in Blender explicitly. In Blender's viewport menu under Face, I select Triangulate Faces and Blender does the triangulation job for me. In the bottom menu, I then can even set different triangulation methods, Beauty and Clip. Anyways, it didn't work either. I get the same weird shading as if the faces were not even. So my next guess was, if the faces are not even, maybe I can subdivide them to get smaller uneven portions. Back in Blender I added a subdivision modifier. It's under Generate Subdivision Surface. But I see that my nice object gets all crumbled. That's because the Catmull-Clark algorithm is softening the geometry by recursively applying splines. Blender offers also the simple algorithm, which retains the original vertex position. I can set the number of divisions, and by unticking the optimal display, I see what the modifier will do to the object when applied. With that, I hop over to DAZ Studio and see what it looks like there. It's better, but not perfect, and it comes with the price of an insanely high vertex count for such a simple object. I'm no shader expert, but I guess I know what happens. Like the subdivision modifier, the shader interpolates and applies splines. But with shaders, it's all about normals. Although the actual mesh might be very simple, the shader will assume the normals gradually to rotate until they match the corresponding face. Don't be picky about my flawed comparison with the subdivision algorithm, but I hope it becomes clear that the finer the mesh is, the sooner the normals become parallel. In fact, I need only 2 coplanar faces and all the weirdness is gone. And now I'm gonna show you how I achieve this. Here I created 2 insets from adjacent faces. We see that the normal vectors are parallel for all the insets faces. But the 2 faces that I meet on the bevel's edge have oddly angled normals. The shader will still create the smooth spline, but since the faces are so narrow, the inset mitigates the effect on the whole object. Moreover, depending on the inset size, it will slightly pronounce and smooth the edges like they are on many real objects. Therefore, insets are the way for me to go. As it turns out, applying the inset to each face separately is tedious, and if I apply it to multiple faces at once, I only get one big inset, so the inner edges would still cause trouble. But thankfully someone at Blender's team had already thought on that. In the Insets menu I can select Individual, and then each face will be treated separately. And even with this setting I can still modify the Inset's parameters until I click in an empty space. Then it's confirmed and I need Blender's undo function to go back. Now I'm eager to use my newly acquired knowledge on my license plate. Before I add the supporting geometry, I must apply the bevel modifiers. I do that by clicking the Apply All button. I can create an inset on the bottom face, nothing easier than that. But do I really want to inset each single face? Remember, the bevels on the cuboid's 4 edges serve a different purpose, and it's good if they are smooth. Now, even though the inset function has cool options, the loop functions are interesting too. If I select an edge and press Ctrl R, Blender performs a loop cut. And after I click, I can move the loop cut along the selected edge. And another click finalizes the operation. My check in DAZ Studio confirms the license plate object renders right. At least it's sufficient for my purpose. Now, before I go on, I want to make one thing clear. After having done the UV unwrapping, I'm pretty much stuck with this quadratic shape. Sure, I can stretch it, but not without also stretching the UV map. My morphing ramp asset video talks about this if you want to check it out more in detail. The quadratic shape is somewhat unrealistic for the use of most vehicles. In Austria, where I live, practically only motorcycles and trucks would use those, as you can see on this Wikipedia page. The much more common shape is 520 by 120 mm, which reduces to 13 by 3 or an aspect ratio of 4.3. If I bring my shape to these measures, I realize that it's not as simple as just stretching it, because then also the bezel would stretch while it must have an even diameter around the whole plate. And the edit mode makes no difference there. But I can move the vertices of the left and the right side individually. To be able to grab all of one side's vertices, I switch on the X-ray mode. Now I box select all left side vertices and move them, but soon I realize that I need to move the left and the right side equally to keep the object's origin centered. Of the various ways to deal with that, I decide for snapping. I activate it by clicking on the magnet button and select Grid as snap target. Now the selected vertices jump along the grid lines and I can make the license plate symmetric. It's a good idea to have some thoughts on how to get the dimensions right, since Blender is not a CAD program. In the Viewport Overlay menu, I set the grid scaling to 0.25 so that my object ends up with the right size. That way I create the dimensions I want my license plate to have, and then I care for the UV mapping. I use an add-on called ZenUV that helps with UV mapping and provides functions to easily switch on and off a checker grid pattern. That pattern makes it easy to judge whether the unwrapping delivered good results. Here it did not, because the grid is contorted. That's no wonder, since I reshaped the previously unwrapped model. I unwrap the model again using the conformal method and I get a way better distribution. The checker grid tells me that the UV map is sideways, not a big deal, however it's less convenient for drawing the texture. ZenUV helps me also with that, but it created a mess in the first place. Luckily it offers different rotation modes, and if I select overall instead of 1 by 1, I'm good. The Fit to UV area function will rescale and reposition the islands, but also makes them overlapping, which is bad if I want to use one single texture image. After some experimentation with Blender's pack algorithm, I get what I want. Finally, I scale the object to the right size. But what is the right size? Since my object is actually a compound of a frame with an embedded plate, only the latter must match the dimensions I got. For the next operation, I need Blender's Measure It Tools add-on activated. Then I select two vertices on the plate face, just where I would hold on a ruler. In the sidebar tab View, I open the entry Measure It Tools. In there, the button Segment adds a measurement between the two selected vertices. And it's already here. It's a bit faint and inconveniently placed, but instead of messing with the many settings the Measure It add-on has, I simply scale my object. Because the measure follows the vertices in real time. The way my Blender was set up, I created my license plate being 6 meters long, so I scale it down until the length is 520 millimeters. I can export the object as it is because Blender does not write the measurement into the OBJ file. As you can see, I created my own export presets, which are based on a scaling factor of 100 between Blender and DAZ Studio. Since the license plate now is scaled correctly, I can rely on the preset. The import into DAZ Studio works also via drag and drop, and my Blender export preset pays off by requiring no additional settings in the quirky DAZ import dialog. Does it have the right size? Unfortunately, the node properties do not show this information, and as far as I know, out of the box DAZ Studio does not offer a simple function for measuring. But I wrote a simple script telling me the selected object's bounding box, which is enough for me to confirm the proper import. It's a bit more than 53 centimeters wide, and that's right considering the bevel around the plate. And this concludes the first part of my video about creating a license plate asset for DAZ Studio. Please consider watching the second part where I create the actual texture for the plate's face.